This is Pre-Calculus Concept 33A. We're going to look at solving some trig equations, and we're going to start off with a couple that are a little bit simple and then gradually add some more difficult trig equations. Alright, so we're going to jump right in with an example, and number one here says solve the following: sine of x equals negative 1/2. So our task in this problem is to give all of the answers that make that statement true. And a good thing to think about here is your unit circle. I'm not going to draw a full unit circle, but I'm going to do a little sketch over here so we have something to look at. On my unit circle, and knowing those values now pretty well, we should be able to think about an angle whose sine, or y-coordinate, would be negative 1/2. And hopefully 7 pi over 6 comes to mind pretty quickly. And if you think about other angles, there's actually another one over here where the y-coordinate would be the exact same thing. So 11 pi over 6. So at first glance, there's two answers to this problem. But if I think a little bit deeper, and keep in mind that the unit circle really is only representative of one trip around the unit circle, I could actually think about other angles that are coterminal with the two angles that I've drawn right there. So a quick example might be something like this. If I started at the positive x-axis and I went all the way around the circle, and then ended up with the same terminal side, that's going to be a different sized angle. That's going to be 7 pi over 6 plus one full trip around the circle, which would be 2 pi. And if I add those together, I end up with 19 pi over 6. Okay, and I could do the same thing on the other angle, 11 pi over 6, and go around the circle. In fact, I could go around the circle 3 times or 4 times or backwards. And so when you start thinking a little deeper, there's actually an infinite number of answers. The good news is there's a pretty easy way to represent that, and that is to take our original answer and simply add 2 pi n. And this notation simply means 2 pi times any integer. So the n in this stands for any integer. You don't have to write this every time. When you see a n in a formula like this, it's implied that it's an integer of some sort. So 7 pi over 6 is an answer, but also is any angle that's 7 pi over 6 plus a certain integer number of times around the circle. Right? So if n was 3, I'd go 3 times around the circle. If n was a negative 6, I'd go backwards 6 times around the circle and then add 7 pi over 6. So that expression is representative of all angles whose terminal side is at 7 pi over 6. And so I would obviously do the same thing in this problem as well. So keep in mind that when you have a simple trig solution, there are actually an infinite number of answers, and this is the representation for that. Alright, let's try a u-try. Your task is to give all answers to the following equation: cosine of x equals root 2 over 2. Okay, hopefully you took a moment to think visually about this problem and where you might have an angle whose cosine is root 2 over 2. Pi over 4 is one such angle in the first quadrant, but there's also another one in the fourth quadrant, which you could actually name a couple different ways, but 7 pi over 4 is what's shown there on your unit circle. Alright, and then again, remembering that there's actually an infinite number of answers, I would actually want to say that the solutions are pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n. Those two statements represent all angles whose terminal side is the same as pi over 4 or 7 pi over 4. Alright, here's one that looks a little harder. The only difference here is I've got a little bit of algebraic work to do. There's also an additional thing here which looks like it's more complicated, but it's actually simpler because it's telling us let's limit our answers to simply one trip around the circle. So the good news here is I don't have to think about the infinite solutions, but rather just the solutions between 0 and 2 pi. And that's pretty typical that your trig equation problems will have a statement like that, which makes it quite a bit easier. You don't have to worry about the infinite case. Alright, so I'm going to move stuff around a little bit. I'm going to add 2 to both sides of this equation. And actually, sorry, let's back up a second. I want to kind of get the cosine on one side, so I'm actually going to subtract 3 cosine from both sides. And on the left side, that will go away, and I end up with negative 2 equals 2 cosine x minus 1. And then if I add 1 to both sides, I get negative 1 equals 2 cosine x. And finally, cosine x equals negative 1/2. So this process is very important. What we're doing is isolating the trig function. So maybe make a note to yourself that you want to isolate the trig function. And once I get to that stage, you're actually at the same stage you were in the last problem, where you basically have a simple trig expression, and you want to think about what the solutions are on your unit circle. And once again, we only have to worry about going around once. Okay, so if I go back up here to my picture and I think about the places where I'd have a cosine of negative 1/2, there's going to be a third quadrant answer, and there's going to be, a second quadrant answer and a third quadrant answer. 2 pi over 3 is the one in the second quadrant. 4 pi over 3 is the one in the third quadrant. Those unit circle values you learned last chapter do not go away. We're using those once again, this time kind of in a backwards way. So 2 pi over 3 is one solution, and 4 pi over 3 is another. Because of my constraint at the beginning here, those are my only 2 answers, and there's no other things to worry about. Okay, you try. Same kind of idea. Take this expression, see if you can give all of the answers in this interval. See what you can do. Alright, hopefully you remembered to isolate the variable, the trig function. So basically I want to get down to where I have sine of x all by itself. And in almost every case you're going to get a special value that's going to be familiar to you, and therefore your answer is going to be one of the special angles, or one or more of the special angles on the unit circle. Again, a picture I think helps a lot, so I have a first quadrant answer here and a second quadrant answer here. At both of those angles, the sine is root 3 over 2, and so my final solution is x equals pi over 3 and 2 pi over 3.